Okay, lesson 5.5 is on rational equations, and so we went through the process today on how do I solve a rational equation, and then we also talked about extraneous solutions. So I'm going to work on number 15 with you. Okay, so what it says is I have 1 over 5x squared, and that is set equal to 6 over 5x plus 1 over x squared. So this time I have 3 fractions, and it's an equation, so I need a final answer that says something like maybe x equals and then whatever the answer is. Okay, that will work to make this true. So how we do this is we say, okay, to add or subtract fractions, they need to have a common denominator. So we go and find the least common denominator, the LCD, just like we did when we added or subtracted. Well, it looks like they need to have a 5 and then 2 x's, so x squared. Okay, so what I'm going to do is give everybody what they're missing. Well, this first fraction, he's not missing anything, so he just stays 1 over 5x squared. And we set him equal to, and it looks like I need to give this guy an x in the top and the bottom in order to make him have our LCD. So it looks like he becomes 6x over 5x squared. Plus, and this last fraction, he needs a 5 in the top and bottom in order to have the LCD. So what he becomes is 5 over 5x squared. Okay, now my 3 fractions have the same denominator, and so literally what we do is we ignore the denominator and we only deal with the top. 1 equals 6x plus 5. And now we just solve the top for the answer that we're trying to find. Subtract 5 from both sides. I get negative 4 equals 6x. Divide both sides by 6. I get x equal to negative, and it's 4 over 6, so I'll reduce that and say 2/3. So the answer that we were looking for is negative 2/3. Okay? If you store it and plug it back into the original problem that we started with, it'll make the equation true. The left side will equal the right side. The only thing that we have left to talk about is this extraneous solution idea. Extraneous solution is when I get a solution that I'm not allowed to have because it will make the denominator equal 0. So what we do is we take the least common denominator and we set each part equal to 0. Okay, and here I actually have 2 x's, so x equals 0, and then another x equals 0. Okay, and let me slide this over. Okay, and we look at each piece and say, okay, what number can I not plug into the denominator? Because it'll let the denominator equal 0. Well, this very first one, the 5 equals 0, he has no letters, it's not true, so I just ignore him. But right here, this x equals 0, and this guy's actually the same. This says that x cannot be 0, or else the denominator would be 0. So watch this. 5 times 0 squared equals 5 times 0, which equals 0. No denominator of 0 is allowed. So our extraneous solution is that x cannot equal 0. So as long as we don't find that as an answer, we're okay. And we are. Our answer is not 0, so our answer can work.